Welcome to this course on Industrial Engineering and Operations Research. I am Uday Shanker Dixit in the Department of Mechanical Engineering at IIT Guwahati. You can see the gate of our institute in this slide. So, today in this first lecture, we will discuss what do we mean by Industrial Engineering and Operations Research, which is a very important course, and it is very important even in this era of AI and data science, etc. So, let me first define what is engineering, so that we can understand the meaning of industrial engineering properly. So, this is one ABET definition. ABET is an accreditation body of engineering, and it defines engineering as the profession in which a knowledge of the mathematical and natural sciences gained by study, experience and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. I have highlighted the key concepts in this definition. First, engineering is a profession that uses the mathematical and natural sciences also. In fact, I would say that it makes use of not only the physics, chemistry and mathematics, but also it makes use of economics and other fields also. And then another highlight is that it utilizes the materials and forces of nature in an economic way, but for the benefit of mankind only. So, it is main focus is on the benefit of mankind. If we are not doing the benefit of the mankind, then that is not engineering. Okay. So, this as per this, now let us discuss that what is the difference between science, technology and engineering. Many people get confused about that. Sometimes people say engineering is basically applied science, and some people will say technology and engineering is same. So, let us clear some definition. There are some differences between them. So, science is basically about getting the knowledge, systematic and properly arranged knowledge of any subject is called science. Say for example, science tells us that F is equal to ma, that means it is Newton's second law, that if you apply more force, then you will get more acceleration. Force is applied force is proportional to mass and acceleration. Another is that you can have ideal gas relation, that PV is equal to mRT. This is how the gas behaves. E is equal to mc square. This is famous mass energy equation of Einstein. So, E is the energy, m is the mass, c is the velocity of the light. So, E is equal to mc square. By this formula, I can calculate that if I consume some quantity of the mass, how much energy it can generate. So, this type of knowledge is called science. It is only knowledge that E is equal to mc square. E cannot be mc cube, E cannot be mc, E is only mc square. So, this is a type of knowledge. Okay. Whether it has a use or not, that is different story. Okay. So, this is knowledge. Technology is what? Technology is something related to some applying some technique by which I can get advantage. Okay. Say for example, everybody knows that this is a block, and then you have got let us say that this is a block, and then you have got a connecting rod here. This is connecting rod of length L, and then you have got crank, and if you arrange it in a proper way like I have done here, it becomes a slider crank mechanism. So, it becomes a device that you can convert a reciprocating motion into rotary motion, revolution of the crank. In one revolution of the crank, 2 strokes of the piston will be complete. So, I have just arranged everybody, there is not much science here. unless we do any analysis etc. It is only that we have got the links, okay, but we have arranged in a very systematic way, so it became a technology. Now what become about engineering? Engineering uses for the benefit of mankind, as I have already discussed in the above definition. It uses traditional knowledge, it can use the technology, it uses environmental science, it knows the information about environment, it uses the physical sciences like physics, chemistry, mathematics, it also uses economics, it also uses social sciences like psychology, organizational behavior, many things it uses, and then it makes this one what thing useful. So engineering is very important thing that which basically can use science also as a technology and sometimes mere judgment about something. So here if we do that, say for example, to make this point even more clear, I am giving the example of ancient door safety technology. See, this is in the old time in villages, they used to have a door like this, big wooden door, and in the night they will place that one portion is inserted there on the left hand side, and on the right hand side they can move and they can put it like that, it can slide. So this is a sliding rod type of thing. This provides additional door safety. That means nobody can break open the door because this is there. Okay, so this type of thing is basically a technique, but without knowing much science, people understood that okay, if I arrange it in this fashion, then I can get a technique so that my door can be safe. So this is called technology. Okay, now engineer will take proper decision. Now engineering needs technology, but sometimes without using much technology also it can accomplish some job. So for that purpose, to illustrate that point, I have just taken one photo from a refrigerator. In the refrigerator, there is one plate is kept here. Here it is written the sides of refrigerator may get warm. This is not an abnormality. This is designed for prevention of moisture condensation. And so this thing has been written. Why it was written? Because earlier when the refrigerator was made, then many customers used to touch that side of the refrigerator and they used to think, oh, it is getting warm. So that means there is some defect in my refrigerator, and therefore what they used to do, they will call, they will complain, and unnecessarily their sales and service people will come, they will repair the refrigerator, but this will create lot of expenses for them. So they decided what to do that. Many solutions were sought. Somebody gave this suggestion also that we can put some insulator type of thing. Proper technological solution may be by putting some insulator so that on the side temperature is not felt. That means temperature can get reduced up to that point, because temperature will keep on reducing from inside to outside as per Fourier's law of heat conduction. So it is possible that if you insulate it, person will not feel high temperature, but then it will be expensive solution. So engineering brain said that what is the need of doing that? Instead you just put a type of that plate, and in that you mention that कि फ्रिज की साइड गर्म हो सकती है, ये कोई खराबी नहीं है. मीन्स साइड्स ऑफ रेफ्रिजरेटर मे गेट वार्म, दिस इज नॉट एन एबनॉर्मलिटी, this is designed for prevention of moisture condensation. So if they have given that, so with very less amount of money they could get solution, although they got deprived of using heat transfer. So it is not that, so person who is expert of heat transfer, he may become sentimental, okay, my heat transfer has not been used, but engineer is not bothered. It's not that heat transfer has to be used at all. If heat transfer is used for the benefit of people, if overall it optimizes everything, it's fine. Otherwise, by putting a plate itself, the purpose can be done. So by that you have understood probably that engineering is a very practical method of getting the optimum solution of the things. Now, coming to once we have defined the engineering, then let us say we define mechanical engineering. So, mechanical engineering deals with the design, construction, operation and maintenance of the machine. This is a simple definition. Wherever machine is there, then naturally that mechanical engineer's role is there. And machine is doing what? Machine is basically, it is a device comprising a number of interrelated parts that makes mechanical work easier by overcoming a load at one end by the application of force at the other end. You can say in early days people were using lever only as a machine, it used to act as a machine and it used to reduce our effort. So, nowadays you can have many machines, of course they use electronics, computer and many things in that, but basically mechanical engineer is only concerned with design, construction, operations and maintenance of the machine to minimize human effort, but for that purpose he may study many subjects, suppose thermodynamics also, but with a viewpoint that it will be useful in IC engine, may study even strength of materials, but the main motive is that my machine component should not fail. So, machine is at the heart of the mechanical engineers. Okay. So, mechanical engineer is very much friendly with machines, and I can say that mechanical engineering is the oldest engineering in my opinion. Why? Because early human beings learned how to use tools. Tools are very natural. People use tools and people also use weapons. Weapon is also a type of tool. So, pebble tools were first used by humans by more than 2 million ago, that means more than 20 lakh years ago people used this type of tool. By archaeological excavations we have found all these type of things. Then potter's wheel was, it is said that it was discovered about 3500 BC. So, many such things were used. So, that means this is basically mechanical engineering. Even now about 2000 BC, I think chariots were used in India, because one chariot has been found by excavation in Sanauli village near Bagpat, Meerut in Uttar Pradesh. So, this is shown here. So, we can say perhaps who can be considered early engineer is Archimedes. Archimedes was born in 287 BC and he died at 212 BC. Archimedes has done many things. You know, Archimedes principle is there, how the body floats. You can determine even the density of an object by Archimedes method, but perhaps he is the first military engineer, that he used engineering for the protection of his country and attacking the enemy. Early days that engine was the word used for basically military weapon, like catapult is also an engine. So, and one who manages those things is called engineer. So, basically we can say military engineering is the oldest engineering. So, in that concept from military engineering emerged the civil engineering. Why we started doing that? Because lot of developments actually took place in military engineering. People kept making the things, but John Smeaton, he is called father of civil engineering, because many things which were developed in the army etc., those concepts he applied for the benefit of society also. So, that is why he is called father of civil engineering. He designed many bridges and many other type of buildings, canals etc. So, this is what John Smeaton, he was born on 1724 and died in 1792. So, probably around that time the civil engineering word came into existence. John Smeaton also of course contributed to mechanical engineering also. He devised a water engine in 1761 and a water mill in 1767. He invented the cast iron axle shaft for water wheels. He in 1782 he built the chimney mill in Britain. He also improved atmospheric engine, erecting one at Chase water mine in Cornwall in 1775. That means he improved atmospheric engine. There earlier basically steam engine was invented quite early, but that steam engine was not much efficient. Okay. So, he contributed to making it somewhat efficient, and later on of course, James Watt invented or rather developed a proper engine which could be used. So, similarly after, so from you as you see that we have John Smeaton also contributed to mechanical engineering, and then basically mechanical engineering can be said to start during time of James Watt. James Watt's steam engine was revolutionary. He put outside condenser and many other developments he did, and then mechanical engineering started dominating. Now after that electrical engineering also came. So, electrical engineering became more popular in 19th century, mechanical engineering was in 18th century. So, I have just highlighted few key events. In 1820, Oersted discovered electromagnetism, and he found that electric current can create a magnetic field. In 1831, Faraday's law of electromagnetic induction was given. In 1879, Edison discovered electrical light bulb by which we can get the light. That was done in 1879, and 1888 Tesla did too much work on the AC power. He demonstrated the feasibility of alternating current power transmission, which later became the dominant form of electrical power distribution. So, this was the electrical engineering. So, gradually as the technology kept coming, then the new branches were created. Now, let us see from electrical engineering, then electronics came. Electronics, 1904 thermionic valve or diode were invented, 1907 triode was patented. In 1940, all discovers that impurities in semiconductor crystals create photoelectric properties, but the breakthrough came in 1947, in the year in which India got independence from British colonial rule. In that year, first point contact transistor was developed at Bell Laboratory by three persons, Bradeen, Brattain and Shockley. So, they got in 1952 first commercial device, hearing aid was developed to apply Shockley's junction transistor. So, for the discovery of the transistor, these three people they got Nobel Prize also. And in 1952-4, first truly consistent mass produced transistor was demonstrated. And then in 1954, first transistor radio came. That is why in early days many people in the villages, they used to call small radio as transistor only. That transistor became, because it was using the transistor technology. And once these things have been developed by electronics, naturally the electronic engineering became very important, and many developments took place like CNC machines etc. They started using too much electronics, and even in computer science also new computer was developed which was more efficient. So, this is about that. So, other things are in electronics, say for example in 1955 silicon oxide was discovered, 58 to 59 integrated circuit IC was invented, 1962 MOSFET is invented, it is basically field effect transistor. So, it was invented. 1966 self aligned gate process for fabricating field effect transistor was developed. 1967 first handheld calculator was invented. Now, everybody knows how to use calculator. 1969 dynamic random access memory was invented. 1970 the first CD-ROM was patented for storing the data, and in 1971 Intel introduced computer on chip. So, all these type of developments have been taking place. You see that how from civil engineering, mechanical engineering came, then electrical engineering came because of developments in electrical engineering, then even the electronics and computer science came. What about industrial engineering? Industrial engineering is a branch of engineering that focuses on designing, improving and managing systems that integrate people, materials, information, equipment and energy. That means industrial engineering is not only concerned about the machines etc., electronic items, but it is overall and how the things will be integrated. The goal of IE is to optimize these systems to improve productivity, efficiency, quality and sustainability. Means he is not content by displaying that okay, see this is working wonderfully, okay this is bulb is giving light. He is more concerned whether it is efficient, whether it is sustainable, whether it is bringing any profit. So I have just to make it in a very simple way, I have just highlighted that what are key factors of industrial engineering. So I can say something like 5M or 6M of industrial engineering. That means industrial engineer is concerned with man, that means human resources, that workforce involved in production and management. He is concerned with the machine, equipment, tools, technology used in manufacturing. Material, he bothers about material, raw material, component and supplies essential for production. Then he is also concerned about method, standardized processes and best practices for efficiency and quality. Mechanical engineer has designed a machine, but in what efficient way the machine should be operated, how the operator sit, how he should use his hand, at what level his eyesight should be there. So this type of things industrial engineer does. Measurement, performance matrices, quality control and data analysis, and money, financial resources, budgeting and cost management, that is also the part of industrial engineering. We can even say that another aim, management, that he overall manages. So you can say he is a technology manager, planning, organizing and decision making to optimize productivity. And he also sees the market, demand, competition and customer needs that influence the production. He does the market forecast also, so that he can plan the production, and of course he is also involved in maintenance also, which other engineering branches also do that. So if we just show you the evolution of industrial engineering, then it will be more clear. In 1750 to 1850, that means this period was first industrial revolution. That time Adam Smith etc. and other people's name also have been mentioned. They focused on these features: division of labor, that means if everybody does some specialized job, then overall productivity can improve. Then replacing muscle by machine, and concept of interchangeability, that means I can make some male components and some female components and they will match properly. I can make some shafts and some holes, they will match properly, that means interchangeable. So they will be like that. And in 1851 to 1930, method study, that what is the proper method to do a thing. Distinct identity of industrial production engineering emerged actually in this period, that means in the beginning of the 20th century. Use of electrical power was common, but then statistical quality control and queuing theory, these were developed in that period. 1931 to 1960 was more human centric. Ergonomics, which is basically the human factor engineering, that means how the mind's body or mind can be used properly, ergonomics. Then quality management, then operations research also developed, which we will be studying as a part of this course. And then in 1961 to 2010, automation, quality, supply chain management, lean and agile manufacturing, Six Sigma, web based production, cloud computing and manufacturing, these got focus. That means how to use information technology etc. This also became this one important. And in 2010 onward, industry 4.0, internet of things, sustainable manufacturing, big data and analytics and digital manufacturing, these became prominent. So this way industrial engineering is basically evolving. Basically core idea is the same, that how to use the resources in very efficient way, but for achieving that there are different type of methods they are adapting, and they are adapting to new technology. Now, coming to the operations research, which is very much interlinked with industrial engineering, but it can be said as a separate discipline also. Operations research is taught not only in mechanical or industrial engineering department, but also by mathematics people. Mathematics people will not study a subject called industrial engineering, but they will study a subject called operations research. So, operation research or OR is a scientific and mathematical approach to decision making and problem solving in complex systems. It involves using optimization, statistics, mathematical modeling and analytical methods to improve efficiency, resource allocation and performance in various industries such as manufacturing, logistics, healthcare and finance. So, when we study that in more quantitative way, then it becomes like operations research. Operations means any activity which we do in industry. So, it is a scientific and mathematical method. In optimization, we decide that how to use resources in very efficient way, and we use many analytical methods and this one. So, if we just talk about some key topics of in OR, then it will be more clear that we study that optimization, that means finding the best possible solution under given constraints. Then we do mathematical modeling, that means representing real world problems using equations and variables. There may be problem of industry, but you do it in the form of mathematics. Then simulations, imitating real world operations to analyze different scenarios, and statistics and probability, that means managing uncertainty and making data driven decisions. Then queuing theory, studying waiting lines to optimize service efficiency, that say many jobs are in the queue, so how to manage them properly. And network analysis, that means optimizing paths, routes and connections in logistics and supply chains. So, these type of things we do study. Now, evolution of OR, that operation research was formally developed during World War II, 1939 to 1945, as military forces sought scientific methods to enhance decision making and resource allocation. So, basically we can say operation research was a task given to mathematicians for improving the military operations. The war presented complex problems in logistics, strategy and combat efficiency, which led to the systematic application of mathematical and analytical techniques. 1939 to 1945, in World War II, the British and American military extensively used operations research to optimize radar deployment, anti-submarine warfare and logistics. In 1947, George Dantzig, he developed the simplex method for solving linear programming problems, which revolutionized optimization. So, these are the basically developments in the optimization, and even OR and industrial engineering and OR both are connected. We can say in that sense that operations research is one subset of industrial engineering. Industrial engineers will use the operations research to optimize everything, but they may not only rely on mathematical things, they may take their own decision based on the sociology, based on the psychology, based on the existing practice, based on many other factors, so that overall growth of the company is done. So, operations research is very much used by industrial engineers, but mathematicians, they also study operations research. Their focus is more on making the algorithms more efficient, developing new methods and algorithms. That is their focus. So, I hope that by this talk you have been clear about the concept of industrial engineering and operations research. Thank you very much.